Let us look at graphs. So first, let me give you an introduction to graphs. So another aspect of this expression, of which we have been uh, looking at addition, subtraction, multiplication, rational expressions, factorization. So now we are going to look at what do they look like in a pictorial form. But before we actually look at how expressions look like, let's have an idea of the background behind or the basic concepts related to drawing these pictures. So this drawing or picture is called a graph. Remember number lines in arithmetic? Numbers were points on a line. But an algebraic expression has only one variable, x. To visualize the expression, we need values of x and a variable y to represent the value obtained when the expression is evaluated at x. So evaluating at x, we have already seen evaluating an expression. So given a value of x, we can evaluate a value for the expression. So basically, it boils down to input-output pairs. So x is the input, y is the output. This input-output pairs of numbers is written as within brackets x comma y, where x is the input, that is the independent variable, and y is the output, which is the dependent variable. So how do we convert it into a pictorial form? We draw two number lines which are perpendicular to each other. This is how it looks like. Two perpendicular lines, each one representing a number line. Any pair of numbers can be shown on this graph, since the number lines represent the real numbers, which include natural numbers, integers, rational numbers, and irrational numbers. This way of representing pairs of numbers is called the Cartesian coordinate system. To make it easier to locate points, lighter colored lines are drawn perpendicular to the x-axis and perpendicular to the y-axis, forming a grid. Now, the different aspects of this Cartesian coordinate system are: the horizontal number line represents the independent variable and is called x-axis. The vertical number line represents the dependent variable y, called y-axis. The entire area of this graph represents the plane called the xy plane. Each point on the plane can be reached if we are given two values, x for how many units to the right or left, and y for how many units upwards or downwards. And from where do we start? Left or right, up or down? We start from 0, 0. And it is called the origin, which is treated as a point of reference. So the intersection of these x and y axis is the origin. The x-axis and y-axis divide the xy plane into 4 quadrants, going anti-clockwise. So we have the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Now let's see how it looks like when we plot points. So basically, identifying the points or locating a particular point for a given pair of x and y values is called plotting the graph. Let us say we are given 2, -2 as a pair of x and y values. Now, where would it fit? So remember, we start from 0, 0. Yes. So usually it is named as O for origin. And to plot the point 2, -2, we go to the right because it is a positive number. 1, 2. So that is going in this direction, 2 units. Then -2. Up is positive, down is negative for the y values. So we go 2 units down. Then in that case, this point A is the point which is addressed by 2 comma -2. As we move this point, the addresses are given there. So this is 5 comma 1. This is 3 comma -2, -2 -4, and -6, 3. Now the axes extend indefinitely in both directions, even though only a small portion may be shown. Sometimes to accommodate the values, we might scale the graph. Usually a unit means 1, but we might specify that a unit means 2 or 3 or a fraction. We might do scaling of x-axis or y-axis or both. This is exactly like looking at a map where it says 1 centimeter is equal to 5 kilometers. Remember, most of the time we are not interested in some random points on a plane. So here, this was just a random point that I was showing you. This is not very helpful except for us to understand how plotting is done of points. We are interested in 2 sets of numbers related by an algebraic expression where one set is the domain and the other is the range of the expression. That is algebraic expression. To draw the graph, we create a table of values with 2 columns. The first column contains the values of x which we provide, and usually we take some negative values and some positive values along with 0. So something like this. We have y is equal to 2x, and we take some values of x and we plug it into y is equal to 2x and evaluate it to get the values of y. So now we get 3 plus 3, 6, 6 x comma y pairs of numbers. And we plot these points on the Cartesian coordinate system. So basically, what is a graph? A graph is a collection of all points x comma y that satisfy the given equation. So there are a lot more additional values of x in this table which satisfy the given equation. So we will in our next session look at that aspect. Here I just wanted to show you how we start off with drawing a graph. Now, if the domain is a set of integers, then we plot points without connecting them. Such graphs are called discrete graphs. If the domain is a set of real numbers, then we connect these points. In such cases, the graph usually forms a continuous curve. Such graphs are called continuous graphs. So that was an introduction to graphs. In the next session, we will look at how these graphs help us in understanding different aspects of these equations or functions. That's it for now. Bye.